Good morning, dear students. Today we are going to deal with the topic test cross. What is test cross? It is back crossing of F1 hybrid with the recessive parent. Back crossing of F1 hybrid. Back crossing of F1 hybrid means the progeny of the F1 hybrid is crossed with the recessive parent or crossed with the parent another parent which have same phenotypic and genotypic of that of the recessive parent of the monohybrid cross. Test cross which account for the inheritance of single phenotypic trait is known as monohybrid test cross. That is, if we are going to deal with only one of the character or deal with one character, then we can say it as monohybrid test cross. And if we are going to deal with the two traits, or if we are going to deal with the two character, then we can say it as a dihybrid test cross. So back crossing of F1 hybrid with the recessive parent is the test cross. Test cross ratio, how it is depicted: cross between two organisms. Next one parent with the dominant character and other with the recessive character. The genotype of dominant parent is unknown. The genotype of recessive parent is known. So we are going to find out the genotype of dominant parent. Even if the dominant parent is appear as dominant character, we have to find out that whether that dominant character is a true breeding. So here in the F1, even though two homozygous parents are crossed, one with the homozygous dominant and other with the homozygous recessive are crossed in monohybrid cross, in the progeny we get is the those with the dominant character. We have to identify the genotype of that dominant character. So the genotype of dominant parent, here we selected that F1 hybrid as the dominant parent, and we have to identify what is the genotype of that dominant parent. So here for the test cross, the genotype of dominant parent is unknown. The only known genotype is the genotype of the recessive parent. How can we identify the genotype of the recessive parent? Because in all cases, the genotype of the recessive parent will be homozygous recessive genes. Then about monohybrid test cross, tall, we are going to deal with the example of height of the plant. One is tall into dwarf, that is F1 hybrid, which is the tall character, is crossed with the dwarf, which is a recessive one. The F1 hybrid is with the unknown genotype. Then the recessive one is with the small t. In the result of the test cross, that is the F1 of the test cross is always 50% dominant character and 50% recessive character. So we can say that test cross ratio is 1:1. How we can explain or how we can convince to others. Explanation: if all the test cross progeny are dominant, then we can predict that phenotype of unknown parent is homozygous dominant. That is, if all the test cross progeny are dominant, then we can predict that phenotype of unknown parent is homozygous dominant. Since 50% of F1 progeny of test cross is with the homozygous recessive, it is clear that the dominant parent is heterozygous. Since in the F1 of the test cross we get half of the progeny with the recessive character, of half of the progeny with the homozygous recessive genotype. Even if the progeny of any cross is with the heterozygous recessive genotype, then we can assure that the dominant parent is not homozygous dominant, it is a heterozygous dominant. Then we can go through dihybrid test cross. In dihybrid test cross, one we can select the same example as of dihybrid, that is yellow round, which is crossed with green ringled. The progeny we get, the yellow round is the F1 hybrid and green wrinkle is the double recessive parent. So the hybrid genotype is unknown and the double recessive is the small y, small r. In the F1 progeny of the dihybrid test cross, it will be 25% yellow round, 25% yellow wrinkled, 25% green round and 25% green wrinkled. So the ratio we can write it as 1:1:1:1. So in dihybrid test cross, we again get all the combinations which we get in the F2 or which we get in the dihybrid cross. So dihybrid test cross ratio is 1:1:1:1. Here, since all the genotype or all the combinations we get, for getting all the combination, it is again clear that the unknown parent, unknown dominant parent is heterozygous. So monohybrid test cross is 1:1 and dihybrid test cross is 1:1:1:1. Dear students, once again going through what we studied in this class. Test cross is a cross which reveal us the genotype of an unknown parent. The unknown parent genotype we can identify only when that genotype is crossed or that parent is crossed with a recessive parent. Even if an unknown parent is crossed with a recessive parent, we can identify the genotype of the unknown parent. Here, by doing the test cross, Mendel identify the genotype of the monohybrid progeny in the F1 and dihybrid progeny in the F1. So I am here winding up and you have to memorize that monohybrid test cross is 1:1 and dihybrid test cross is 1:1:1:1. Thank you.